All right, so we're diving deep today into the world of 3D computer vision. It's pretty amazing, right? Like, we're talking about machines actually, seeing the world in 3D.
Yeah, and we've got some really interesting research and insights to dig into today.
Totally. So, when we talk about 3D computer vision, it's not just like taking a 3D picture, right? It's like giving machines this like understanding of space.
Exactly. It's like they can understand spatial relationships, almost like they can touch things, but without actually, touching them.
Right. It's like giving them a whole new sense, like a spatial awareness, that we just kind of take for granted.
Exactly, like depth perception, for example. We do it without even thinking. But for a machine, that's really complex, right?
Yeah.
But we're teaching them to do it, using algorithms to analyze images and look for clues like shadows or textures or even like how objects overlap in an image.
So they can like figure out how far away things are just from a flat image.
Yeah, it's called monocular depth estimation,
Mhm.
and it's opening up all sorts of possibilities.
Like, give me an example.
Well, think about a drone, right? Flying over, say, a disaster zone, taking pictures. And then those pictures can be used to make a 3D map of the area. That could really help rescue teams, navigate difficult terrain.
Wow, yeah. Okay, so that makes sense. And I know we got to talk about robots because 3D computer vision is huge for robotics.
Totally. With 3D vision, robots can actually operate in like dynamic environments. Not just like on a factory floor doing the same thing over and over again.
Right, so like more advanced stuff.
Exactly, like helping surgeons in the operating room or
Mhm.
exploring, the ocean floor or even, helping out with like chores around the house.
So robots are becoming more like us in a way with this 3D vision like helping them interact with the world.
Exactly. They're not just stuck in the lab anymore. They're out in the real world.
So how does it actually work? Like what's going on inside the computer, so to speak?
Okay, so one of the key things is something called a point cloud.
Okay, a point cloud. What's that?
So imagine like millions of little dots, right? Each one is like a point in space. And by analyzing these point clouds, uh, algorithms can, build a 3D model of whatever they're looking at.
So it's like putting together a 3D puzzle.
Exactly, like a jigsaw puzzle,
Mm.
but with points instead of pieces. And the more points you have, the more detailed the model is.
And that's why like multiple cameras are better, right?
Yeah. It's like how we use two eyes to see depth. It's called stereo vision.
Hmm.
By comparing the images from two cameras, the algorithm can calculate the distance to objects.
So we're basically teaching machines to see the world the way we do.
Yep.
But they can handle like way more visual information than we can,
Exactly. And they can process it all in real time.
which is like super important for things like self-driving cars.
Right, totally. They need to make split-second decisions. So real-time processing is crucial.
Yeah, so self-driving cars, they use like cameras and LiDAR and radar, all that stuff, right?
Right.
To create this like 3D map of their surroundings.
Yep. And that map is constantly updating, allowing the car to, make decisions about steering and braking and all that.
So it's almost like the car has its own like personal space bubble, like it knows where everything is around it and can predict how things are going to move.
That's a great way to put it. That spatial awareness is really important for self-driving cars to, operate safely.
It's really kind of crazy to think about. Like we're actually getting closer to that sci-fi future we always see in movies, where machines are like a part of everyday life.
It's amazing.
So speaking of like creating things, we got to talk about 3D modeling, right?
Mhm.
Because that's another area where 3D computer vision is just blowing up.
Absolutely. 3D modeling is being totally revolutionized by 3D computer vision.
It's like giving machines the power to sculpt in the digital world.
Right. Like imagine you take a bunch of photos of, I don't know, like a really nice face, a really old antique face, right? And then the software can stitch those images together and make a digital copy of that vase, like down to every little detail.
So you're like capturing the essence of a real object in the digital world.
Right. And then you can do all sorts of things with that digital model. You can analyze it, you can share it, you can even, 3D print it.
So the possibilities are pretty much endless.
Pretty much. Like architects are using it to design buildings, video game creators are making these incredibly realistic worlds, and museums are even using it to, preserve ancient artifacts.
Wow. So it's like It's like we're breaking down the wall between the real world and the digital world.
It's really amazing, and it's not just about preserving the past either. 3D modeling is really changing how we design and manufacture things too.
Oh yeah, how so?
Well, imagine, right, being able to like create a virtual prototype
Yeah.
of anything, and then you can test it, in a simulated environment before
Yeah.
you ever have to like actually build
Oh,
anything.
it's interesting, like a
Yeah,
digital sandbox.
exactly. And that lets you, experiment with different designs, see how they work, before you waste time and money building the real thing.
That's super cool. So, okay, I want to jump to something else that I think is just awesome. Augmented reality.
Ah, yeah, augmented reality,
Yeah.
where the digital and physical worlds kind of, come together.
Yeah. And 3D computer vision is like essential for that, right?
Absolutely.
Like I can imagine, right, like walking through a museum and you see like 3D models of ancient artifacts right on top of the real ones, or using your phone to see what a new piece of furniture would look like in your living room.
Yeah, those are great examples. It's all about, adding digital information to the real world and making it look real. And that's where 3D computer vision comes in.
Oh, it's like giving our phones superpowers.
Yeah, kinda.
But it's more than just, fun and games, right?
Well, yeah, for sure. Like think about surgeons. They could use augmented reality to see inside a patient during surgery. Or engineers could, use it to see like repair instructions right on top of whatever they're working on.
So it's like having X-ray vision.
Yeah. Or like a heads-up display, right in front of you.
So augmented reality has like huge potential in healthcare and education, all sorts of fields.
Yeah, absolutely.
Yeah.
It's pretty amazing what we can do with it.
So we've been talking about all the amazing things we can do with 3D computer vision, but there are challenges too, right?
Oh yeah, definitely. Like one of the big ones is just how complex the real world is.
Yeah.
It's messy, it's unpredictable, and it's tough to make algorithms that can handle all that.
Right, like you can't just program a computer to understand like every possible situation.
Exactly. There's just so much variability in the real world.
So 3D computer vision is awesome, but it's not perfect.
Yeah. And we need to be, really careful, especially when it comes to things like self-driving cars. We got to make sure those systems are reliable
Yeah.
and safe.
So it's kind of like we're building the airplane while we're flying it.
Right, yeah.
Yeah.
That's a good way to put it. It's cutting edge stuff, but we got to be, cautious.
Okay, so I wanna end this part of our deep dive with a bit of a thought-provoking question.
Okay, I like it. Shoot.
So 3D computer vision is blurring the lines between the real world and the digital world, right? So what happens when we can create virtual worlds that are so real that you can't even tell the difference? What does that mean for reality,
Wow. Yeah, that's a deep one. It really makes you think about, what's real and what's not.
Yeah, like how do we even know what's real anymore?
It's almost like that thought experiment, right?
Yeah.
The brain in a vat.
Yeah, exactly. Like what if we're all just living in a simulation?
Who knows, right?
So as we move into this future where the lines between real and virtual are getting blurrier and blurrier, we really need to think about the ethical implications of all this, right?
Absolutely. Like privacy, security, even our sense of identity. All of that is going to be affected by this technology.
It's a lot to think about.
It is.
Yeah.
It really is. But it's exciting too,
Yeah, it is. Like it's almost like that brain in a vat thing, right?
Yeah, it really is. And the more advanced this technology gets, the more we're going to have to grapple with those kinds of questions.
It's like what if we get to a point where we can create these virtual experiences that are so real that it's impossible to tell the difference. I mean, would we even want to?
That's a good question. Maybe we'll reach a point where the line between real and virtual just doesn't matter anymore.
Yeah, maybe like we could be, jumping back and forth between physical and digital worlds all the time. Like using augmented reality to enhance our real world experiences or even experiencing things remotely through virtual avatars.
Yeah, and who knows, maybe we'll even be interacting with artificial intelligences that are so advanced that they feel just as real as any human being.
It's pretty mind-blowing to think about.
It is,
Yeah.
but it's also, a little bit scary. I mean, we have to be careful, right?
Oh yeah, absolutely. That we can't just blindly rush into this future without thinking about the consequences.
Exactly. We need to make sure that these technologies are developed and used in a way that benefits everyone, not just, a select few.
Right. We need to have like some serious conversations about privacy and bias and access, all of that stuff.
Yeah, we really do. It's not just about the technology itself. It's about how we use it.
Well said. Well, this has been quite the deep dive. I mean, we've covered a lot of ground
What's
today.
that?
We've talked about how 3D computer vision is giving machines this incredible ability to see the world in three dimensions, and how it's being used in everything from robotics and manufacturing to healthcare and entertainment.
And we even touched on some pretty deep philosophical questions, about the nature of reality itself.
Yeah, we did. It's clear that 3D computer vision is a truly transformative technology, and it's only going to become more important in the years to come.
Oh, absolutely. I mean, we're just scratching the surface of what's possible.
So as you go about your day to day, just take a moment to think about all the ways that 3D computer vision is already shaping your world.
Yeah, it's everywhere.
I mean, from the facial recognition on your phone to the self-checkout kiosks at the grocery store, it's all around us.
And who knows what the future holds. I mean, maybe we'll see, robots that can perform like incredibly complex surgeries,
Yeah.
or self-driving cars that are totally safe,
Mm.
or even virtual worlds that are so realistic that they're basically indistinguishable from the real thing.
It's exciting to think about. Well, on that note, I think we're gonna wrap things up for today. Thanks so much for joining us on this deep dive into the world of 3D computer vision.
Yeah, thanks for having me. It's been fun.
And to all our listeners out there, keep exploring, keep questioning, and keep imagining the future
Hmm.
because it's gonna be here sooner than we think.